do that one together. So they've got 22% of the goal. Couldn't I word this that 22% of the goal is 18,700? Could I reword that problem that way? Isn't that what they're telling me? They got the 18,700. That's 22% of the goal. If I word it that way and I use proportions, it's almost like it gives me, proportions are great because they give me a place to put everything. When I see the percent and I'm doing a proportion, I know I'm going to make a fraction equal a fraction, right? So this 22%, you know that one of your proportions is going to be the one where you represent the percent, and you're just going to represent it as 22 over 100, aren't you? Now, do you remember that when you do proportions that I told y'all when you see the word of, that the whole, because remember we're doing parts to whole on these, the whole is going to come next. Do I know the whole? The whole goal here? I don't know the whole goal. I know the part is $18,700, right? But of the goal, we don't know what that is. That's the missing thing. We want to know the whole part they want to raise, not just the part they've already raised. So that whole is missing. I'll just put an X. If you kind of think, is the number they give me a part or is it a whole? Oh, it's part of it. They're wanting to raise more money, aren't they? So we don't know the whole. If I write it like that, then all I have to do is cross multiply. I would say 22 times X is 22X. And then 10 times this 18,700, wouldn't that just be that 18,700 with two more zeros on the end? And then if I want to solve it, I would just divide both sides by 22. Now, I'm not going to finish that out here just because y'all have calculators, and that's an easy thing to do. I just want to focus on setup today on some of these easier ones like this because there are going to be some harder ones pop up later. Okay, so we got a 3% sales tax. That's a state sales tax. That's state. There's a 1.5% county tax, sales tax. Boy, they're getting hit everywhere. And a 1% municipal sales tax. That's like a city sales tax. So every time you buy something, you got to pay all these taxes on everything you buy. How much tax will she pay if she buys a $340 bicycle? Well, you kind of know if you go in the store, you got to pay she got to pay her $340, but then she's got to pay tax on it, and they're just asking us for the tax amount. They didn't actually ask us for even the whole amount that she's going to pay. How much taxes does she have in all in percentages? Couldn't we just add those up? Yeah, it's just 5.5, 3, and then 1.5 make 4.5, and another one make 5.5%. So she's got 5.5%. We could write that as what, 5.5%? Now, I'm not going to multiply by 5.5 because remember when I multiply, I never multiply by percentage. I have to change it to a decimal. How do I change that to a decimal? Yeah, just move it over 2 places. I'll need to fill in with a 0. So all I'm going to do is multiply 340 by 0.055. Of increase and decrease. Okay, so we're going to have some problems in 7.6 that have to do with percent of increase or decrease. And these problems, you work them similarly. You're always just going to say it's the difference between the original amount and how it changed. So you're going to subtract the amount they give you from the original amount, and then you always put it over the original amount. That's going to give you a decimal you're going to find. So you'll get a decimal value once you divide that out, and then you're just going to change that decimal into a percent. Remember, to change a decimal into percent, you move the decimal place right 2 places, don't you? Okay, so this is the big idea of what's going on. So let's look at number 1, just because those are problems. Most of the time, people that usually get percents have trouble with percent increase or decrease. Number 1 on 7.6, this is the problems that we're looking at. I'll go back to the original ones later. I think the word problems usually are what gets people. So this is the word problems on 7.6. It says the population at Dos Pueblos High increased from, so the original amount is 1,800, right? But then it increased. What did it increase to? 1926. That's 10 years later that it grew that much. What was the percent increase? Okay, so remember what we said is you're just going to subtract those two amounts. So what's 1926 minus 1800? Yeah, so it's 126. If I subtract these two values, and then I put it over the original amount. What was the original amount? 1800, okay. So I'm just using this, up here. That's what I'm doing. And then when I divide that out, I'm going to get a decimal. I will just scoot my decimal place over. After I get my decimal, to change it to a percent, I'll scoot the decimal place over 2 spots, and I'll have my percent, okay? That's what you're going to do there. Let's just kind of go through setup on some of these. Okay, number 3. A $200 coat is on sale for, sale price is $166. What's the percent of discount? How are you going to have to figure that out? When we need to find the percent of decrease, wouldn't that do it? Isn't the percent of the discount the same thing as the percent of the decrease? Because you're paying less, so it's decreasing, isn't it? Okay, so remember what we just did. We said we take and subtract the two amounts. So it was 200, it's going down, so I'll put 200 minus 166. That's going to be what, 34? And what was your original amount? 200. So if I divide that out, I'll get a decimal. Anybody have a calculator handy to tell us what that is?
5.88.
That may be the percent. Shouldn't be. What was the decimal number? 0.0588? Is that what y'all are getting?
Yeah.
Okay. Okay. So now that's the decimal, and then to change the decimal to a percent, you'd move it over 2 places to the right. So there, yeah, you were telling me the final answer there. It's 5.88%, and it went down, so it's a decrease.
5.88, and so I was like, oh, I must have done it wrong.
Oh, no, okay. So what did you get? What did you get?
I got 0.078.
0.078.
0.017, whatever she said.
Okay. I don't have a calculator, so I'm kind of trusting y'all. Y'all divide that out. Everybody divide that out for me again, because...
0.17, no, I see it.
Okay, 17, and after that was like what? Because we'd want to, if we need to round it up, we need to know that. I tell you what, I'm just going to, 17, like that? Okay, so if that's what it divided out to be, we would move the decimal place over 2 spots. That's why I need you all to be working on your calculator together when we're in class, because if you're just counting on one person to do it, they may not even be on the same problem as you, something can happen. If we're all typing things in the calculator, we catch things like that quicker, okay? But if you're just relying on one person to type it in, this kind of thing is going to happen all the time, and we're going to stay confused. So all of you should be have your calculators and be working together so that we catch these things.
Yeah, so
Okay, that's okay. That's all right. But that's the deal. If everybody were doing it, then more than one person would have known. When it just comes down to one person's word against the other, that makes it kind of hard. So 0.1717, move the decimal place over 2 space. That's 17%. If we round to the nearest percent, they didn't say they wanted us to round, but that's what they're doing. If you look at the key. While on vacation, Allison noticed that a $5.50 breakfast actually cost $5.83 because of the sales tax. So what's the sales tax rate? There's a lot of ways you could do this, but the simple way to do it would be to say, okay, isn't this your original amount? And this is your change, your new amount. It's the changed amount. Couldn't I subtract those two? If I subtract them, what would I get?
33.
Yeah, so it's 33 cents out of the original. What was the original cost? $5.50. Okay. So if I divide that out, and I need everybody that has a calculator to be doing this now, because it's easy to accidentally enter a wrong digit in a calculator. So it just is, all of us doing it is what's going to help us catch those kind of things. What do we get when we divide that out? 0.06. Go out a few more decimal places. Remember, we might need to round or something. Always try to go out 4 before you change something into a percent. Is it even? Is it going evenly? Oh, it goes in evenly. Okay, thanks. Thanks, okay. I just didn't know if it went in evenly or not. Okay, so it goes in evenly. So that's your decimal. Change it to a percent. Move that decimal place over 2 spots, and it would be 6%? What? Quick, okay, so for number 7, it says Yvonne paid $11,448 for a new automobile. The amount includes the 6% sales tax. What was the price without the tax? Okay. So, okay. We know this is the total price. We may have to set up an equation for this. There may be a way to do it without an equation, but just like my first thought is, do we know what if we wanted to do the percent change is 6%, right? But do we know what the original was so that we could subtract it? Don't they want us to find the original amount? Okay, so here's what you could do. Again, there's a lot of ways to do this. I always try to think, well, what if I were stuck on a ACT or SAT test and they were asking me to do this, what might be the fastest or the easiest way to do this? Well, if I had the original amount here, isn't the original amount going to be smaller than 11,448, right? Because they have to add the tax on that. That's what makes it bigger. So I could say, well, since the 11,448 is a bigger amount, let's say it's that minus the original amount. That would be the change that would have occurred. And remember, we want to put it over the original amount. And the original amount, we're going to call it X. So let X be the original amount. If I knew it, I would just subtract it from this total. And then I would divide by the original amount. And I'd have my change. But now, am I going to put 6 here? Haven't we, every time we did this, don't we end up getting like the decimal amount and then we change it to a percent? Mm-hmm. So all that change would be 6%, but I'm going to call it 0.06. Now, I got a fraction on one side and I got something else on the other. Do you remember that if you got a fraction on one side, you can make the other side into a fraction just by sticking it over 1, even if it's, even if it's a decimal, you can do that. You can say stick this over 1. You could cross multiply. You could say 0.06 times x is 0.06x. And then on this other side, you could say 1 times that 11,448 minus x. 1 times anything is just itself. If I want to solve this, I could just say, well, you know what? I have a minus x here. Couldn't I add x to both sides and I'd get all my x's on the same side? Normally, I would have moved the 0.06 x over to be with the 1x, except it was a negative x, so it was much easier just to add it to both sides. That way I don't have, negative numbers. And that's a 1x. What is 0.06x plus 1x? Is it 0.07x? Is that what it would be? Right, good. It's 1.06x is equal to the 11448. And you might have thought that at the beginning. There's like 5 or 6 different ways I could think to solve this problem. If I want to find out what the original amount is, now all I got to do is divide both sides by 1.06. And I'll have it. And I'll let y'all divide that out, but according to the book, what you should be getting is 10,800. Is that what you're getting when you divide that out?
If you 10,837 or?
Oh, does it have like 37 cents? Okay, so divide it in evenly. Okay, good. So yeah, that's what the book says.